I hope you are doing okay. So this is lesson 3 on sets of numbers, and we'll concentrate on real numbers. Remember I said that real numbers consist of both rational and irrational numbers. Okay, so we know that there are a lot of methods we can use to represent sets, of which one of them is by using a Venn diagram, by listing, by describing, even using set builder notation. So those are just some of the methods used to represent sets. Then in this lesson we have to know how to represent sets using a number line, and that is what we call interval notation. Representing sets using number line, call that interval notation. So apart from representing sets on a number line, we should also know how to use the different types of brackets when representing sets. Okay, so we know that we can have these, the curly brackets, or simply the braces. Apart from curly brackets, we also have these round brackets, or simply parentheses, the round brackets or parentheses. And finally we have the square brackets. So we can use curly brackets, the round brackets, or the square brackets in order to represent sets. Okay, so I'm sure we already know how to use the curly brackets when representing sets. Let's say we have set A consisting of the natural numbers. Let's say the first 5 natural numbers. So 1, 2, 3, 4, 5, like that. Set A representing the first 5 natural numbers. Okay, then how can we present set A using the round brackets and using the square brackets? So when you use round brackets and the square brackets, just to show the first and the last element, so you just show 1 and 5 there. So the same set A can be represented using the square brackets, so we just show the first and the 5, and the first and the last number, they are separated by a comma. So first and the last number 5. So we have represented set A using these square brackets. Now what is the difference? We're representing the same set using square brackets and using round brackets. So let's use round brackets. So here we are using the type of real numbers we are using here. We are saying natural numbers. Okay, so we are using the first 5 natural numbers there. So let's represent it using round brackets. So when you use a square bracket, it means that this first element you have written is part of a set. Now when you use round brackets, you write the element which comes before the actual element you want. Okay, so here we'll write 0. So this simply means that 0 is not part of the set, but when you listing the elements, you start from 1 and so on. So it will be 0, comma, the last element you know is 5. So instead of writing 5, you write 6, like that, 0 to 6, meaning that 0 there is not part of the set, but the next element. Then 6 is not part of the set as well, but the previous element is part of the set. Then there are some cases we can use both round brackets and square brackets. Let's say set A being equal to, so if I start with a square bracket like that, 1 is part of the set, I'll write it, comma, then I end with a round bracket. So I will not write 5, instead I'll write 6, like that. Same applies, set A can be represented like this. I start with a round bracket, so instead of writing 1, I'll write 0, so that we start counting from 1. This 0 is not included, comma, then we move on to, let's say I use a square bracket like that. So instead of using 6, I'll use 5. Okay, So this is how you use round and the square brackets to represent sets. Now for real numbers, these actually, let's say we have a situation where 2 is less than or equal to x less than or equal to 7. 2 less than or equal to x less than or equal to 7. So here we have a lot of numbers between 2 and 7. Between 2 and 7, there are a lot of numbers. Apart from 2, we can't go direct to 3. Even 2.1, 2.2, 2.001, 2.002, and so on. All those numbers are between 2 and 7. Now, so it's almost impossible to list all the numbers here in the case we are using inequalities. As a result, it's easier to represent this case using round brackets or square bracket. So whenever you use less than or equal to, so whenever you see less than or greater than, just know that you use these brackets like that. Then whenever you see less than or equal to or greater than or equal to, just know that you will use square brackets like that. So in this case, you have less than or equal to less than or equal to. So to represent this one, you say 2, 7 like that. Otherwise, if you are the situation like 2 less than x and less than or equal to 7, automatically before 2 you should use a round bracket there, 2, then 7 like that. Same applies if you have something like 2 less than x less than 7, it will simply be 2, 7. So this is how we use the round brackets and the square brackets. I hope you get the concept. Then let's look at some situations we'll be encountering when solving questions. Some situations we'll be encountering. So the first one is an open interval. So for an open interval, you have a situation where you have used only round brackets. Let's say we have used A and B. So A and B are representing n numbers. This is just in general. So for A and B, how can we represent such on a number line? So we'll do that. A number line, you show A and B like that. Okay. Then on top of these numbers A, B, you have to draw circles. Then you join them. Then these circles can be shaded or can be left open like that. So whenever you use a round bracket, like this, that circle should be left open. Then whenever you use a square bracket, that circle should be shaded. That's the thing to take note of. For round brackets, circle open. Then for a square bracket, circle should be shaded. Okay. So for this one, this side before A, say round bracket, circle open. This side, circle open, because we have used round brackets. Then how can we represent this one? Using set builder notation. So using set builder notation, since we are using real numbers, we say X be a member of what? Real numbers, such that. So this is just from A to B. There we are describing this region only from A to B. So we can say A is less than X less than B. And again, take note, we have used less than because of the round brackets and not being shaded. Then that's such that you can use a full colon or simply a bar like this. This is also such that that's one and the same. So that's it for an open interval. Then you also have half open interval. So you can have half open interval or half closed. So for half open interval or half closed, you have, let's say you have started with a round bracket like that, A. Then for B, use a square bracket, meaning this is half open, this side is open, this side is closed. This is half open or half closed. Then representing this one using number line, meaning it will be on A you do what? B, then on top circles, you join the two lines. So this side where we have A, it's a round bracket, don't shade. Then with square bracket, they are shading that circle. So that's how you go about it. Then you can describe this region. They are joined by a line using set builder notation. So you will say X, let X be a member of what? Real numbers, such that, so we are dealing with real numbers, such that, so this A is less than X, less than or equal to. I've used less than or equal to because it's shaded there and even B is included. Just like that. So you can also have a situation. So for half open, even this side, you can also have a situation like this where this A, before A we have used a square bracket, then after B use a round bracket. Then representing this one using a number line, meaning it will just be like that. That's A, B, then circles, circle, you join them. After you join them, you check. So for A, you shade it because of the square bracket which has been used before A. Then this side B, you leave it open, meaning B is not part of the set. Okay. Then using set builder notation, we say X, member of real numbers, such that, so as you can see, A is less than or equal to X, less than B, like that. So that such cases you can have. Okay, then for an open interval, what if you have used infinite? What if you use infinite? So we can have another case of an open interval. In the case where you have used positive infinite or negative infinite, let's say you have A, comma, infinite. This is positive infinite. So in this case, how do you present it? Using a number line. So on your number line like that, you simply show this one number or a letter which you have. Of course, this is the number line, you'll be dealing with the numbers. So A there. Then on top of A, so you don't show that no, maybe infinite there. No, you don't do that. So on top of A there, a circle. Then we have round brackets. So don't shade on A. Then infinity is this side. This is positive infinity, meaning to your right. You go to your right like this. So that's it for this one. Then we can also represent this one using set builder notation. So say X, member of real numbers, such that, so if you see, we have X being, we have X being what? Being greater than A. So X greater than A. X greater than A. So X greater than A. So it's A going this side, greater than. Okay. Then what if we have used for the same open interval? What if this time around we use, let's say, so it will be negative infinite, comma, B, like that. Okay, so negative infinite should always be this side on your left hand, this side. Okay. Then actually let me even extend it like this. Since this B will be there, then as you can see, after B I've used a bracket which is open there, around bracket, so don't shade it. Then for negative infinity, where do you go? Is it this side or this side? Of course, to your left, this side. Negative infinite, just write an arrow there, meaning you are going all the way to negative infinite. So you just leave it like that. So meaning for this one, set builder notation will be X being a member of what? R, such that X is less than what? Less than B, meaning we are going all the way up to infinite like that. So these are just some of the cases. You'll be encountering when solving questions. Then you should note that for negative infinite and positive infinite, you can't use square brackets. So you can't say negative infinite, then use a square bracket like that. No, you can't use a square bracket before negative infinite or positive infinite. You can't use a square bracket. In the case where you say, let's say, negative infinite to positive infinite like that, you can't use square bracket. This is wrong. You can't use square brackets. If you use square brackets, it means that you know the last number, what the last number is. Now, if you don't know the last number, like for infinite, you don't know the last number. Remember, always before infinite and after infinite, negative infinite and positive infinite, always you use these round brackets or the parentheses. Don't use square brackets. Okay. So from these explanations, we can now solve some questions so that you apply what we have learned. Okay. So we just do that. So let's solve some questions. So these are questions which I have for you. So question 1, let A be equals to, so we're using set beta notation there, x be a member of R representing real numbers such that negative 7 less than or equal to x less than or equal to 3, and B equals to x being a member of real numbers such that x is greater than or equal to negative 1. Then find A intersect B to find A complement using the number line and put your answers in set builder notation. So here we are solving using the number line. So we find A intersect B and A complement using the number line. So let's get the A which we have there. So inside I'll say solution. Okay, solutions. Then question 1. So for question 1, I'll get the A which we have A, x being a member of R such that negative 7 is less than or equal to x less than or equal to 3. So that is A which we have. Then B we have x being a member of R such that x is greater than or equal to negative 1. So these are the two sets we have. And the first thing we should find A intersect B, and we should find A complement using a number line. Okay, so what you do when you have been given such cases in set builder notation, the first thing, you convert what you have been given to interval notation. By interval notation, we mean we represent the set using square brackets or round brackets. So we have curved brackets, represent them using square brackets or round brackets. So from set builder notation, let's represent them using square or round brackets. So this is negative 7 less than or equal to x less than or equal to 3. So as you can see, we have used less than or equal to, less than or equal to. Then this simply means we're using square brackets. So negative 7 comma what? 3. The first element being negative 7, last being 3. So that is A using square brackets. Then for set B, let's represent it using square brackets as well. So as you can see, this is just x greater than or equal to negative 1. So we are moving from negative 1 to infinite because it's greater than or equal to negative 1. Just know the first element, but the last element we don't know it, meaning it's infinite. So due to greater than or equal to, using a square bracket, then negative 1 to what? Infinite. Always, as I said, after infinite, we using a round bracket. So we have represented A and B like that. Then let's go to the first one, finding A intersect B. So to find A intersect B, you draw your number line first. You draw your number line. Then you show the elements which you have. So as you can see, for A we have negative 7, 3, negative 7, 3, So negative 7 can be somewhere this side. Then that 3 can be somewhere this side, positives. Can be somewhere this side to the positives. Then this negative 1, of course you expect it to be somewhere this side to the negatives. So for this one, it's not necessary to show all the numbers. Let's say you show 0, 1, 2, 3, 4, 5, 6, 7, even this side, negative 1, negative 2, negative 3, what? Don't do that. Don't do that. What if you have negative 100 there? What are you going to do? Is it possible to list them all? Of course, the space won't be enough. So just show the numbers which you have there in your set, the first and the last one. Okay. So for A, set A, let's show set A on this one. So on top of set A there, on top of 7 for A, you draw a circle. Then even on top of 3, this is for A, you draw a circle like that. Then you join them the same way we're doing the introductory part. You join them like that. Of course, you can even use your ruler so that it can be neat. Then what you do, you shade. So you shade it like this. So we have shaded set here. But on top of 7 there, as you can see, we have used that square bracket. What does this imply? We should shade. Even on top of 3 square bracket there, we should shade like that. So this is set A. This is set A. If you want, you can even write this is set A. Then on top, okay, let's move to set B. Set B is starting from what? Negative 1 to infinity. So on negative 1 like that, you draw a circle just like that. Then to infinity, we are going to the right. This side is positive infinity, so we go to the right. Since it's infinite, just show an arrow like that. Then due to this square bracket, meaning you shade that one, because it's a square bracket. Make sure it's shaded. Okay. After that, also shade set B. So this is set B. Shade it in the opposite direction. You shade it like that, in the opposite direction to A. Shade it like that. So our aim is to find A intersect B. So the intersection is where the lines are crossing. So as you can see, in this region, the lines are crossing. So that is where the intersection of A and B is. So this is the intersection of A and B. That's where its intersection is. So for A intersect B, we can say it's from what? Negative 1 there to 3. This region is what? Shaded. That is for A intersect B. Otherwise, for A intersect B, A intersect B, as you can see, the region which is shaded is from negative 1 to 3 there. So meaning A intersect B. Now let's take negative 1 is part of what? The set. So it's negative 1, comma what? Comma 3. So just get the region that is shaded. That's how you go about it. So that's the first one. In the second one, we are finding A complement. So to find A complement, what do? You get first set A. Get first set A itself. So let's show set A on a number line. So set A, that's from negative 7 to 3. Then on top, you do the same. So it would be shaded like that. Then you join these points. So what do we want? It's A complement. So this is A, meaning A complement outside A. As you can see, A is just negative 7 to 3, meaning starting from 3.1 or 3.01 going this side, even this going this side from negative 7 going this side, that is A complement. So on top of 3 there, you draw another circle. We want to show A complement now. so it will go all the way up to infinity. Even on top of what? Negative 7, you show a complement. It will go up to negative infinity this side. Then, since this negative 7 is shaded, meaning it's already in a complement, it won't be there. So leave this open. So this is a complement, and this is a complement. You use even this one, leave it open. This 3 is already in A. It's already in A. Since it's already in A, it won't be found in A complement. So you leave that circle open. Okay. Then let's represent this one now in interval notation using square or round brackets. So we are saying A complement equals to, so this side, where is it going? It's going to negative infinity. So we say negative infinity, comma, up to 7 there, negative 7. Then this negative 7 is already in A. So in A complement, we want to use a square bracket. Instead, use a round bracket to show that it's not in A complement. Instead, it's already in A. Okay. Then union. So we have two parts for A complement. We have this part and this part. So you combine them using union. You come this side. It's 3. We are starting from 3. And for 3, it's open there. So using round bracket 3 to what? Infinity. So that's it for A complement. That's how you go about it. Okay. Then, if we are to write these in what? Set builder notation. Of course, this one in set builder notation, it should be X being what? A member of R, such that, so it's from negative 1. So say negative 1 less than or equal to X less than or equal to 3. Just like that. Then for this one, using set builder notation, it would be, so we write this one in set builder notation alone, and this one in set builder notation alone. So say X being a member of real numbers, such that, so here you simply say X is less than negative 7, since we are going this side. Then union, separate them using union. So say X member of R, such that, so for this one, X is what? Greater than 3. That's how you go about it. So that's it for the first question. Let's go to the next question. So for question 2, let R, the set of real numbers, be the universal set. So the set of real numbers is the universal set in this case. Then we have set A there. So set A, that is actually negative 7, 8, union 11, infinity. That's set A. Then set B, we have been given set B, which is what? 0, 20, 0 to 20. Then find the following sets and display them on the number line. So we should find A complement. The first thing is to find A complement. So A complement. How do we find A complement? Let's first show A on a number line. So we have to show set A on a number line. So for set A, as you can see, the first part of set A, we have from negative 7. So let's first show these numbers first. So it's we have from negative 7, but from negative 7 on this area is also 8 there. But from 8, we also have 11 somewhere this side. Okay. Negative 7, 8, and 11. Then on top of negative 7, the first part, just we deal with the first part, negative 7 to 8. So the first part on top, you draw a circle, then a circle like that. So before negative 7, we have a square bracket, meaning it should be shaded like this. Shade it. Then just join the two. This one is being left open because we have a round bracket there. Then for 11, so 11 to infinity. So on top of 11 there, you draw a circle. Then going to infinity. This is positive infinity. So it's this side like that. Then before 11 we have used a square bracket, meaning you shade it. Okay, so meaning this is what? Set A. This is set A, set A. So you check which regions are remaining. So only have this region, that's the one remaining. Even the region this side is remaining, because the region this side is taken. So the remaining regions are the ones for A complement, meaning from -7 there going this side, this is A complement. From -7 going this side, it's A complement, like that. Yes. Then even between 8 and 11 we don't have A there, meaning it's A complement. Between 8 and 11, that is A complement, like that. Now as you can see, 8 is not part of A, meaning it's A in A complement. So since this is not shaded, we shade the one for A complement. So this is A complement. Then for this 11 is already in A. So for A complement, you leave it open. Okay, then let's write now our answer using square brackets or round brackets. So meaning A complement will be equal to, so from this side where we go into negative infinite, so it's negative infinite, comma, -7. Then union, it's between 8 and 11. Then for 8, square bracket, 11, round bracket. So that's it for this one. Set builder notation, it should be X being a member of what? Actually for this one, they don't even want set builder notation. But if we were to write X will be a member of what? R, such that, as you can see, this is X is less than -7. Then union, separate them using union. Okay, then from 8 to 11, so say X member of R, such that 8 is less than or equal to what? X less than 11. Yeah, that's it. If at all set builder notation was wanted. Then the second thing, we should find A intersect B. We should find A intersect B. To find A intersect B, meaning we should show both A and B on the number line. We shade and check where the lines are crossing each other. Okay, so that's the number line. Let's show set A. We know that set A, that's from, we have -7, there's also 8 and 11. Then for B, what do you have? It's 0 to 20. We know that 0 can be found between -7 and 8. So we can write 0 there. Then 20 should be found after what? After 11, of course. 20. So that's set B, 0 to 20. Okay. So let's start with set A. We show it the same way we did there. Set A only. So for set A, on top there, we draw circles. Then before 7 square bracket, meaning we shade. Then you simply join the two. Then even on top of what? 11 is part of the set, you shade. Then you are going this side like that to infinite. So this is simply A. Then you do the same for B. So this B is actually from 0 to 20, and both 0 and 20 shaded. Okay, so you do that on top of 0, even on top of 20, like that. Then you join the two and shade them. Okay, shade them like that. So this is B. After that, what do you do? Start by shading the region for A. So these are the regions for A. This region and that region there. Also shade the region for B. So we are shading it in the other direction. Shade it in the other direction. Then, as you can see, B is ending there. Okay, you know that part. So we have shaded A and B. Then check where the lines are. The lines are crossing each other. So that region and that region, the lines are crossing each other. So that's the intersection. Therefore, you can say A intersect B will be equal to, so A intersect B will be equals to, so it's from 0 to 8, 0 to 8 there, okay. So it will be from 0, and as you can see, 0 is in both what? A and B. So meaning even the intersection it will be found. So no wonder I use this square bracket 0 to 8 there. Then let's check from our brackets. In A we have 8. We don't have 8 due to that bracket. Then in B we have 8, 0 to 20. So we use an open bracket like that. Then union, so it's from 11 to 20 now, from 11 to 20, and it's square bracket like that. So that is A intersect B. Okay, so that's it for question 2. Then let's solve our last question. Question 3. So for question 3, we have, so represent the following on a number line and write the interval in set builder notation. So the first one is actually negative infinity, comma 4. Okay, so you can, if you want, you can pause the video, try to solve, then you continue. So negative infinity to 4. We show this one on a number line. So we are simply showing a 4 there. So you can have 4. Then on top of 4, it's a square bracket used, you shade it. Then where is negative infinity? Is it this side or this side? Of course it's this side. So simply draw a line like that. So I have shown on a number line. Then using set builder notation, we say x being a member of R such that, so here we say x is less than or equal to 4. That's it. That's the first one. Then the second one which we are showing is simply negative 1 to 3. We are showing this on a number line. So do that. Then negative 1 can be there, 3 this side, on top. So you say, if you check, we have used this square bracket, so shade, even 3, shade, just join them like that. So that's it. Then using set builder notation, it will be x member of R such that, so it's negative 1 less than or equal to x less than or equal to 3. That's it. And the last one, we have negative infinity, comma 1, then union, we have 2 to infinity, like that. So you draw your set, your number line, then check what numbers do we have. We just have 1 and 2 there. So 1 and 2. Okay. Then on top of 1, so before, after 1 we have a square bracket. So we shade it. Then negative infinity, it's this side, like that. Then for this one, on top of 2, again it's shaded. You go to the right, like that. So that's it. Representing that one using set builder notation, x member of R such that, so you start with the first part, then the second part, such that, so you can see that x is less than or equal to positive 1, it's just 1. Then union x member of R such that this part now x, so it's greater than or equal to, we are going to the right, greater than or equal to 2. Okay, so that's it. Hope you have enjoyed the lesson. This is it for this video. Hope you have understood. See you the next lesson.